right, warm up. Let g of x equal this fourth degree polynomial and find the derivative, the rate of change at the point or the x value of 1, and use it to write an equation of tangent line to the graph of g at the point 1, negative 1. What does this function look like on a graph of fourth degree? Let's go to decimals just to show you what it looks like. Here we go, let's go to decimals. Decimals, x to the fourth minus 2. So we got what? Y equals x to the fourth minus 2. So that's what it looks like, and it said at the point 1, 1. So y equals x to the fourth minus 2. This is what it looks like. And no, at the point 1 would be negative 1. If you plug in x is 1 here, you still get 1 minus 2 is negative 1. At the point, let's go here. So that is at the point 1, negative 1, right there. So yes, right here. And what would be the slope there? Okay, so here, what would be the slope here of the tangent line? What is that slope? All right, so that's what we're trying to look for. It looks to be some steep positive slope. Let's go back to doing it, to working it out. Let's leave that and let's go ahead and go back to the whole slideshow. Okay, so we got this equation. We want to know what is the slope there. Okay, so it is 1, negative 1. So we got the equation of the line, tangent line. All right, so let's go ahead and do it. So most of the information is y minus y1 equals mx minus x1. We're going to plug in x and y and then minus. We got our x1, y1, x1, y1. So x is 1, x minus 1, and we got the y1 is minus 1, which makes it positive 1. And we're trying to find this. We need calculus. All right. So which definition are we going to use? We got those two definitions. I'm going to go ahead and do the second definition. Always seems to be the easiest to use algebra with. So we're going to use what? F prime at a equals f of x. Nope, I forgot the limit as x approaches a of f of x minus f of a, x minus a. So this is the second definition. It seems to be the easiest to use. Okay, let's go ahead and do it. So what we're going to do is we're going to do f prime at what input? Our input is 1, f prime at 1 of this function. Okay, so f of x, well, we don't have f of x, and in reality we have g. So why don't we just change this g prime at 1? Because we can go ahead and change the name of it, g prime at 1. Instead of using f, because it's not an f function, it's a g function. So g prime at 1 will equal to g. This is g, and this would be g, and this is g. So g of x, well, g of x is x to the fourth minus 2. Okay, and now we're going to evaluate, we're going to minus what g of a is, minus g of 1. Okay, and then we're going to have x minus 1. Okay, so we continue on. We have g prime 1, g prime at 1 is equal to x to the fourth minus 2. And now we're going to minus what g of 1 is. Go back to plugging in g of 1. X is 1. This is 1. 1 to the fourth. That's 1 minus 2 is negative 1. So this is going to be negative 1. All right. And now at the bottom we have x minus 1. Let's continue. So this is going to be x to the fourth. And then we have minus 2 minus a negative 1, which makes it plus 1. So minus 2 plus 1 is negative 1. Then we got x minus 1. I keep forgetting my x approaches what? 1, lim x approaches 1. Lim x approaches 1. Okay, so how do we do this now? If you plug in x equal to 1, you're going to get at the bottom 1 minus 1 is 0, and that we cannot have that. We got a problem here. At the top, maybe we can factor this out. That looks to be like a difference of squares. So we can go ahead and do g prime at 1 is equal to, at the bottom, let's put that x minus 1. X to the fourth minus 1 can break down to be x plus 1, x minus 1, x squared minus 1. So we got x squared plus 1 times x squared minus 1, that is x to the fourth minus 1. And we can go ahead and break it down some more, this one right here. I keep forgetting my limit x approaches 1. Lim x approaches 1. So we're going to have x squared plus 1. And we got x squared minus 1 is what? X plus 1, x minus 1. Over x minus 1. Oh, and now here we can cancel out that x minus 1 here. So we can cancel out this and cancel this out. So then we're going to get the limit as x approaches 1 of x squared plus 1 times x plus 1. And now we can go ahead and substitute x equal to 1. Alright, so if we plug in x equal to 1, you're going to get what? 1 squared plus 1 times 1 plus 1. So what is that? That's going to be 4, no? 1, this is going to be 1 squared is 1, and you got 2 times 2 is 4. So the slope is 4. So the rate of change at that point is 4. And we are done. That should be the equation of the tangent line at that point. Okay, that would be it for this warm-up.